Doing some practice. All right, so we left off somewhere around here. We were talking about Fisher projections, and we wanted to designate these two compounds as being R compounds or S compounds. The first one is an amino acid, and yeah, let's take a look at this one. Did anybody figure out if this one was R or S? I'll throw that out there to my students first, since I know you probably worked on it really hard. Okay, let's take a look. We got some differing responses here. So the nitrogen is going to be number 1. The hydrogen will be number 4. This carbon is attached to oxygen, oxygen, oxygen. This carbon is attached to oxygen, hydrogen, hydrogen. This is our tiebreaker. And so the carbon on the top is going to be number 2. So I'll just erase that to clean things up. This is number 2, and this is number 3. So we go from 1 to 2 to 3 around the stereocenter. So that would be S, and we reverse it to R, right? Because remember, the proton is coming out towards you. And so this is an R compound. So we'll scribble that here, R. And then for the second one, our highest priority compound or group is going to be the oxygen. Then this is going to be the last. This will be the second. This will be the third. So we go from 1 to 2 to 3 around the stereocenter. That's R. We reverse it since the hydrogen is coming out towards us. And so this is an S compound. So they are R and S with respect to the order that they are on the page. Okay, well, let's move on to section 5.8. This is more of an FYI than anything, I think, but it's really fascinating when you think about it. It says molecules can rotate around single bonds. So if I was to show you a molecule of butane, right, and I said, draw me a Newman projection looking down the carbon 2. So this is, carbon 2-3 bond, what would it look like? Well, you could draw either one of these conformations here. These are both gauche conformations. You could also draw the anti-conformation, but you see that these are the two gauche conformations, okay? Again, there's 2 of them. Now, if you look at these 2 conformations, which are in equilibrium with each other, do you notice that they're actually enantiomers, right? If you look at them, they're mirror images of each other, and they're non-superimposable. So you take a molecule, butane has no chiral centers in it whatsoever, but we see that we end up with 2 conformations that are actually enantiomers of each other. So if you're wondering, well, what's the consequence here, or what's your conclusion? Well, remember that we do have free rotation around the carbon 2-3 axis, and so on account of that, the fact that these rotamers are interchangeable, that they exist in an equilibrium, they cancel each other out, so to speak, and so butane is not a chiral compound. So don't worry about it. Butane is not a chiral compound. We have another case here. If you have cis 1,2-dimethyl cyclohexane, so all this is the chair form of cis 1,2-dimethyl cyclohexane. If we look at the molecule drawn this way, okay, in a bond line structure, it's very clear that it's a meso compound, and so therefore it's going to be an achiral compound. But if you look at the 2 chair conformations that I have shown here, it's the same compound, but these 2 chair conformations are enantiomers of each other. And so again, if you're wondering, well, what's the consequence here? Well, since these chair conformations are rapidly interconverting, that means that they overall cancel each other out. And so there's still a plane of symmetry in the molecule, and so it's still considered to be a meso compound. Again, it's just more of an FYI thing. I don't remember asking any students. Maybe 1 question out of 100 or something might have something like that in it. Okay, we're going to skip sections 5.9 and 5.10. I will not ask you any questions about those sections. However, you do have to know section 5.11, and you have to know it well. And when we're dealing with double bonds, when we're dealing with alkenes, and we can't designate the alkene as cis or trans, then we have to find a way to differentiate between stereoisomers. So these 2 compounds are definitely diastereomers, right? They're stereoisomers, right? But they're not enantiomers, so they're diastereomers. But we can't use cis or trans to differentiate between them. Because if you remember, when we have a cis compound, we have 2 groups that are identical on the same side of the double bond. And when we have a trans compound, we have 2 groups that are identical on opposite sides of the double bond. Here you can see that on our double bond, we have 4 different groups. We have an ethyl, we have a fluorine, we have a hydrogen, and we have an amino group, a nitrogen containing group. So we have 4 very different groups. So we can't use cis or trans in this case. Well, if you're wondering, why did you save this till the end? Because it's partially related to the Kahn-Ingold pre-log rules that we looked at earlier on. If you remember, the Kahn-Ingold pre-log rules were the rules that we used for designating RNS. So let me show you quickly. What you do to determine whether a compound is E or Z is you look at each one of the carbons in the double bond. I'll highlight this one in red and this one in blue. So you start with the carbon in red and you look at the 2 atoms that are attached to it. So here we have a carbon, here we have a fluorine. Which one of those has a higher atomic number? The fluorine. So the fluorine is going to take precedence. Then I look at the 2 other groups. I have a hydrogen and a nitrogen. Which group is going to take precedence? Well, the nitrogen has a higher atomic number. It's attached directly to the carbon. And since those 2 groups are on the same side of the double bond, it's a Z compound. And Z stands for, I don't know how good your German skills are, but don't zusammen. I don't know. How do you spell zusammen? It's probably on the next page, is it? Yeah, it is on there. Zusammen. Hey, what do you know? I spelled it right. Okay. So zusammen, which is, again, if you speak German fluently, don't beat me up for this, but I think it means together, or in proximity or something like that. So zusammen is together. And then if we look at this compound over here, you can see that we have this carbon in blue, and we'll do this one in red. Well, the one in red, the nitrogen's up here, and the one in blue, the fluorine's down here. So we say that this is an E compound. And E stands for entgegen, which is opposite. My students taught me years and years ago, E for opposite, right? So E for opposite of each other. Anyhow, if that helps you, that's good. All right. So again, cis and trans only works when you have a like group on the each carbon of the alkene. All right. So I've gone over the rules for assigning E or Z to a compound. And so again, Z is zusammen or together, and E is entgegen or opposite is the correct way of describing it. So with all that in mind, let's see if we can determine whether this alkene here, would you call this an E compound or a Z compound? Let's start with the carbon in blue. And if you look at this carbon here, it's attached to a carbon, and a hydrogen, whereas this one is attached to a carbon, hydrogen, and hydrogen. This is my tiebreaker. And so this group is going to be the higher priority of the 2. On the carbon in red, I have a hydrogen that's not shown. And then I have an isobutyl group. The isobutyl group is obviously going to be a higher priority. And so how would you describe this compound? Would it be E or Z? Not a trick question. No, they're on opposite sides, right? If you look at the carbon in blue and then the carbon in red, right? You have the isopropyl group going up like this, and then you have the sec-butyl group going down like this. So they're on opposite sides, right? So this would be an E compound. And then if we look at the compound below it, so let me zoom in a little bit here. On the carbon in red, I have a chlorine and then I have a carbon. So the chlorine is going to take precedence. And on the carbon in blue, I have a hydrogen going down and then I have a methyl group. Well, the methyl group is going to take precedence. Those are on the same side of the double bond. And so this would be a Z compound, a zusammen compound. All right, give me a thumbs up if that makes sense now that you see it. Now that I kind of revealed the answer. Okay, cool. So you can imagine that on the quiz, it's very easy for me to, get it? Easy. Oh man, I just came up with that. It's very easy for me to ask you a question about E and Z. All right. So what we're gonna do now, just give me 2 shakes, just give me 2 shakes of a lamb's tail here. And what we're gonna do now, oh, Not right now, honey. Okay, so what we're going to do now is we're going to take a short break and we're going to come back and we're going to tackle these problems here, which deal with chapter 5. So stereochemistry, isomers, cis trans, easy, all that good stuff. And so we have a total of, I don't know how many problems are even in here. A few. Oh, jeepers, there's quite a few. Anyhow, we'll see how far we get, but we'll come back. Um, in either way, I'll post the solutions to them no matter what. So it's 10:24. Why don't we take a break and we'll come back and then we'll give you a chance to try some of these problems and we'll come back and take a look at them.